All right, 4.3, determinants and inverse matrices. So your objectives first is to find the determinant of a matrix, and second, you're going to find the inverse of matrices. Remember, essential question you need to think about while you're working the problems and listening to the videos. Homework packet, problems 29 through 44. All right, a determinant of the matrix. The notation is determinant of the matrix A is equal to determinant A equals the absolute value of A. So the determinant of any matrix is the absolute value of A. So when you're evaluating a 2 by 2 matrix, you're going to multiply these two numbers together and then subtract the product of these two numbers, B, C. So when you have a 2 by 2 matrix, you're going to take A times D minus BC. Doesn't matter what AD and BC are. If you follow this rule, you'll find the determinant every time for a 2 by 2 matrix. All right, so here's one example. What is the determinant of the matrix A? Now I know in your packet you didn't have parentheses around these numbers over here, so make sure you add those in. So we have a negative 3, 1, 7, negative 9. We're going to multiply negative 9 and negative 3, subtract 1 times 7. It's important whenever you're multiplying two numbers together, put them in parentheses so that way you won't make a mistake when you're multiplying. So you have 27 minus 7 is equal to 20. So the determinant A is equal to 20. All right, let's do this example. So first of all, we have the determinant is equal to AD minus B times C, or C is B, DA, doesn't matter. So we have 9 times 6 minus 7 times 3. So 54 minus 21 is equal to 33. So the determinant for this matrix is 33. So we're going to go ahead and evaluate this matrix, find the determinant. So the DET, we'll just call it determinant, is equal to negative 7 times 6 minus 5 times negative 9. Remember, it's always the upper left times the lower right minus the upper right times the lower left. So negative 7 times 6 is negative 42 plus 45. Be careful, you have a negative times a negative. So the determinant of this is equal to 3. Evaluate the determinant. So the determinant is negative 3, make sure you're using parentheses, times 3, minus 8 times negative 8. So it's equal to negative 9 plus 64. So the determinant is equal to 55. 64 minus 9. Okay, let's go ahead and evaluate this determinant. It has fractions in it, but just do it the same way. So we have the determinant is equal to parentheses 1 times 10 times 10 minus a negative 1/2 times 2. Remember, put all four numbers in parentheses. You'll never make a mistake on the negative signs. Now, the determinant is equal to, we know when you have a whole number, it's 10 times 10 times 1, excuse me. So we have 10 over 10. I'll break it down a little bit this time, right? Minus, actually a plus, 2 over 2 equals, so the determinant is equal to 1 plus 1 equals 2. So the determinant of this matrix is 2. This is very important again, that's why we put it in parentheses. Negative times a negative is a positive. Okay, evaluate the determinant. All right, the determinant is equal to 2 times y minus negative 6 times x. So the determinant is equal to 2y plus 6x. So there's nothing really we can combine or simplify here. We don't know what x and y are. We just know that we found the determinant based on the matrix given. All right, the identity matrix. The identity matrices are square matrices, meaning they have the same rows and same columns, and with ones on the main diagonal from the upper left to the lower right and zeros everywhere else. So the identity matrix for a 2 by 2, 2 rows and 2 columns, has the ones from the upper left to the lower right. See something? There we go, skipped one. The identity matrix of a 3 by 3, as you can see, they use the I with little subscript 3. The ones are all in the upper left-hand corner. Starts in the upper left-hand corner, goes all the way down the right-hand corner. Same thing with I4. If you had I5, you would have 5 rows and 5 columns. So if you had I5, so you have 1, right? So it'd be 0, 1, 0, 0, 0. So you can get the identity matrix from continuing on. You can do I6, I7, just get bigger and bigger. But you just have to know that the identity matrix will give that identity back. We'll give you the matrix back when you multiply by any identity matrix. All right, finding the inverse of a 2 by 2 matrix. If you have a matrix A, then a to the negative 1, which is read A inverse, is found by using the following formula. All right, so we have a 2 by 2 matrix. So this formula down below here to the left is how to find A inverse. Given this inverse, we use this formula to solve for A inverse. Well, what's kind of interesting is that when we do this, we first have to find the determinant of the matrix. You can see down here that this right here is the determinant of that matrix. And then what else they did was they're going to multiply it by, they reversed, you can see here they reversed A and D, the positions. They left B and C the same, but they changed the sign of B and C. So whatever B and C are, the signs get changed. D and A switch positions. So A inverse is equal to 1 over the determinant of A times the matrix, which they switched D and A's position, and they changed the sign of B and C, which is left in the same position. All right, so here's the example. Find the inverse of A, -3, 5, -5, -2, 4. So they found the determinant, -3 times 4 minus -5 times -2. So they switched the positions. Here's the position switch. And they changed the sign of 5 and 2. But they left them in the same position. So now 1 over the determinant is 1/2 times the inverse. So 1/2 times this new matrix that we created. We multiply 1/2 by each term, or each entry into in the matrix. And so when we multiply, we get -2, 5/2, 1, -3/2. Now, the way you can check to make sure if it's an inverse, if you multiply the original, if you take the inverse that you got, -2, 1, 5/2, -3/2, and you multiply it by the original matrix, which is -3, -5, -2, -4, it will equal the identity. It will equal the identity, which is so you can see here where we take, so we're going to finalize everything. I'll show you. First you take -2 times -3 minus 2 times 5/2. So you can see it's 6 minus 5 is 1. -2 times -5 minus 5 over 2 times 4, -4. Nope, sorry. Plus minus. So we get 10 minus 10, which is 0. Let's do the bottoms. So 1 times -3 plus -3 times -2 so we have -3 plus 3 is equal to 0, And then the last one, we have 1 times negative 5 plus negative 3 halves times negative 4 negative 5 plus, oops, yeah, negative 5 plus 6 is 1. So when you multiply the inverse times the original matrix, you get the identity function. We will continue with part 2.